Hello, welcome to the latest edition of Data Unchained. I'm your host, Molly Presley. For those of you who have not listened to Data Unchained in a while or maybe new to the show, let me tell you a little bit about the podcast. As you think about how data has been generated over the years, it was generated in a big data center next to maybe a mainframe computer. And then over the years, as edge and IoT and cloud computing became more prevalent, data has increasingly become more distributed and decentralized in where it's created, as well as where it's used. If you think about the time frame through COVID and then the advent of cloud computing, where there's big compute clusters in the cloud that are maybe not local to your organization, how you get the data that's been generated to the place where you want to use it has become increasingly complex, but also strategic for organizations. Data Unchained digs into both the challenges as well as the solutions tied to data and the use of data in different markets and use cases. And today we're going to be talking about the bioinformatics space. Joining us today is Mark Izraelson from MiLaboratories. Mark, thank you for joining.
Thank you for having me.
And you are, I guess the best way to put it is, in a couple of roles there. You're a senior bioinformatician, and you're also the head of bioinformatics support. What does that mean? Tell us a little bit about what you do day by day and maybe how you got to this point in your career.
I'm originally trained as a molecular biologist, and I've been working at the laboratory as a wet biologist for about 10 years, and we would study immune system. And while working there, the laboratory, we started to develop in the software to analyze that specific type of data, which is immune repertoires. It kind of allows you to access the immune state of your immune system. Because we saw that there is nothing offered in the field which is of the quality that we require, we just developed our own software along the way. At first it was an in-house software, and then we developed a company out of it. We first started doing it with the software which is called MiXCR. Part of this group that were developing software and work closely with the software, we kind of branched from the laboratory and started a company. So I'm in the role of the bioinformatics scientist there. I'm also moved from just doing the bioinformatics for the company to interacting with clients. And we have a lot of clients so far. We have all of the major biopharma companies using our software, the names like Moderna or AstraZeneca or Illumina are all our clients. So there's a constant flow of different requests, how to analyze the data, how to help them benefit from our software, and I'm taking care of that, making the presentation of the software, describing the algorithms, how it works, and then lead the client, supporting them along the way to reach the goals that they have.
Great overview. And so when you think about MiLaboratories and the software that you build and sell, how would you summarize? You said it was a gap that you identified in the space and software that you decided to go ahead and build the software and solve. How do you summarize really what that gap was? What was the pain point?
I think the pain point, at that time, we started 10 years ago, or even more right now. It was the beginning of 2010s, I think. And basically the gap that there was no software to do the job, to analyze that type of data. And we developed our own, we published it, and we have several publications that are highly cited in Nature, Nature Biotechnology. Also, because we come from academia, we understand that our software is going to be used not only by pharma companies, but also academia. And we have this idea that all of the software we design is free for academic users. We only sell it for a commercial use. Everything we do is free for academia because we all come from this field and we understand how important it is to have an access to the software.
Kind of crowdsource some of the community into the software. So when you think about the key problems in bioinformatics related to data sources, understanding structure of data, manipulating data, how does your software at MiLaboratories help to simplify, or like you say, I know you said makes it more consistent instead of building your own, but kind of how does it help an organization?
First of all, it is a graphical user interface, and MiXCR is a part of this graphical user interface. So like you don't need to use the command line. You just drag and drop files. You can like visualize, create plots, everything with a graphical user interface, which a lot of people are familiar with.
Yeah.
The second part is that in bioinformatics, most of the time, you use not only like one particular software, but it's usually a pipeline of different softwares. And like you get the input of the first one is the output of the first one is the input of the second one, and there's like a chain of software. So the idea behind Platforma is it is a place where we can create different apps for different softwares that are already in use, not only MiXCR that we developed, but all of the other open source softwares that are out there. We give this graphical user interface to those open source softwares as well. So you can use Platforma not only to work with MiXCR and not only to analyze the immune data, but also to if you just work with any kind of NGS data, we're going to be adding step-by-step different apps to work with that type of data. Another thing is that analyzing the data usually requires a lot of power, and most people don't really use their laptops to analyze the data. And hence the command line. We usually like remotely connect to the server via like SSH or any other way and perform the analysis on the remote server. And our graphical user interface will also allow that. So like you can have this software opened on your local machine, but at the same time you manipulate the files that are out there on the server.
It's interesting. There's quite a trend. I get the opportunity to talk to different industries doing this podcast and also in the work that I do. And that idea of the local experience on your laptop to remote data sources is such a common theme. And of course, each industry needs to solve it with the tools and the apps that are appropriate for their industry. But it's such a powerful thing to be able to let you use your computer, your own machine, the way you want to, but connect to the world, so to speak. We see in visual effects a lot. You're doing the Stranger Things visual effects, and artists are trying to work collaboratively with remote data sources, but use their visual effects tools. And this is the same thing, but for scientists. It's so cool to see the overlap.
Yeah, and I think like just like at this point, it's something that is really required because nowadays we generate lots of data, and it's just impossible to process it on your local computer. And at the same time, all the cloud computing like AWS clusters, like it's became so available, so like more people can use it. Like you don't really need to probably have a cluster like in your laboratory. You can just get a subscription for AWS and use their capabilities to run MiXCR.
Who do you sell to? Who uses your technology? Which type of person is it, or is it both IT as well as scientists, or kind of what does that look like?
It depends. Most likely, it is. If we're talking about companies, it is an R&D a lot of the time. So, for example, a company or a startup that develops cancer vaccines. All analysis that you want to like create the goal is like creating some kind of medicine which uses your immune system or requires you following the immune response. That is where you gonna need our software like MiXCR and Platforma. But at the same time, since we are expanding and accumulating different apps, now it's basically any startup that is based on NGS data analysis. So like whatever you do, if you're like developing some kind of technology that requires NGS data analysis, you can use Platforma to do that in a way that is more convenient. One of the issues is that really like there's usually a team of bioinformatics who you have like, and then there's a scientist, or I don't know, like someone who's responsible for actually doing like creating the ideas, and there has to be like a constant communication between those teams, like between some like the science teams and bioinformatics. And here we're trying to like give all this power of standard analysis to the scientists so they can easily iterate over different theories without like actually trying to like without reaching out to bioinformatics, wait for them to process the data, wait for them to send back the results.
So, Mark, can you tell us a little bit more about the types of information that a scientist might get out of the visualization and plots? Maybe go in a little more detail on that.
Yeah, we start with usually with NGS data. We start with the regular sequencing data, which is most common data type is FASTQ files. Then you process these files with again either only MiXCR or different software, and we also have a block which allows you to visualize the data and create almost like publication ready plots, because like how it usually works right now. So you use these softwares that are mostly command lines. Then you get some tables and of data, and then you have to like usually use some code. Like people use mostly Python or R to generate plots, compare groups. You have some numbers, you have some metadata. You have like I don't know, like two groups of patients with, and you want to like compare I don't know, like vaccinated group versus unvaccinated group, like disease versus control, and all of that we've been able to accumulate into our software. So like here you can not only process the data, you can attach the metadata to every sample, and you can create different plots like compare like bar plots, compare the groups between each other, different heat maps. If we're talking for about the immune repertoire analysis, one of the important things is the somatic hypermutation trees. That is like the thing that a lot of immunologists are looking for, so you can track how the immune system adjusts to the antigen, and that's usually you can visualize it in a form of a tree when like one clone gives birth to another one, and like there's like a tree develops. Also, we apply a level of statistics there. So like not only you can plot things, but you can evaluate the statistical significance when you compare the groups between each other. And one hard thing here, which we had to overcome, and like we spent a lot of time thinking about it. So like we are trying to, while giving the opportunity to create different visualization options, we're trying to guide the user so he gets only the result that is meaningful. Because a lot of the times you can just like click something and create unmeaningful plots that would like not mean anything. So like here we're trying to, depending on the types of data he wants to visualize, we guide him to the process what visualization will be best to emphasize the point that he wants to, as well as given the statistics that is required. Because like yeah, the statistics is like a whole other thing. You have to like know how it works, and that's actually one of the major concerns, because biologists a lot of the times do not know how to use statistics, how to apply it. And there has been, I believe that I read once a study that there's like, I don't really remember the number, that like astonishing number of the publications fail to pass the statistical testing, because the biologists
Interesting.
do not, yeah, like because it's like a different profession, like a lot, and a lot of the times you kind of
Sure.
like see I don't know, so you see the difference and you think, oh yeah, and you publish it, but then at the same time you did not apply the correct statistic method.
Yeah, so it may not
So
be
here,
statistically relevant or proven, right?
Yeah, and it's a lot of, and yeah, like the number of such publications is actually, weirdly enough, very high. And what are we trying to do again? Because we know the data, because like has been generated within our environment, within Platforma, we can recommend the statistical method that will most likely give you the correct and statistically efficient outcome.
It's interesting in this world where everyone's wanting to use data and it's not my data on my machine that I create and I'm creating information from, but now it's shared and many people are working on it. It's really interesting. Same from my side, watching, a data scientist perhaps can create all kinds of insights from data, but only some of them are relevant. Like they're answering questions, but they're not the questions that the business or the scientist needs. And then the scientist wants to create information and it may not be statistically relevant. So you have to pull in the statisticians. It's like this world of deriving data insights requires a lot of different fields and to make sure you're creating something that's relevant. And of course, AI is making that even worse because it may or may not be accurate, the things that it's doing.
Of course.
And I love seeing solutions like this. The company that I work for helps in unifying the data plane and the data to a single data set. But that's only helpful if the applications or the scientists who are using it are being able to use it to answer the questions they want and know what the data is. And so unifying the application space is such a huge step forward for the industry. I'm curious, personally, I'm curious. There's a lot of standard bodies in the biotech space, whether it's related to HIPAA or collaboration and research and things like that. And do you see that there's a standard occurring, or is it more technologies like yours that are helping to bring together 4 or 5 things and just simplify? Will there be a standard, or will there still be a lot of choices for a while?
I think we are now at the this point in time where the standards are being the different softwares are kind of being developed, and I think that pretty soon we can see there will be a standard to analyze a certain types of data, and we are already being reached out by different academic societies. And I think that in the nearest future, there will be a standard for different types of data, how you can analyze it, and which will increase primarily, first of all, reproducibility, and that as well, because it has to be you have to be able to reproduce the analysis using certain software and be sure of the result. So yeah, I think the standard is coming, and the idea behind the Platforma actually is to become the standard for bioinformatics scientists.
And we didn't talk about it yet, but as you and I were chatting before the show, you mentioned that you also help with resource management. Would you go into a little detail on that as well?
One of the problems that also basically any bioinformatics faces, and may probably even the whole team of bioinformatics scientists, is when you analyze the data, you have to first of all you have to organize it, and then you apply different set of parameters to the software. Half a year pass, and you look at this data, you already do not remember what parameters did you use, how this data was obtained. You're trying to reanalyze this data, you get the different results because you don't remember how it was processed. That's the one thing. Then the second thing is there's a lot of duplication of the data occurs when you are trying to you analyze the data in one way, then you thinking, okay, I want to tweak this parameter, analyze it again. And a lot of the files that are going to be created is actually, you already have them. It's already only a tiny part of your analysis actually had to be rerun instead of rerunning the whole thing. So what we are doing, we are carefully following when every output file is generated, we're carefully following its history. And if we see that you change the parameter and you run the analysis again, but I don't know, 90% of the analysis has already been done, the software will see that and it won't run the part that is not required. It will only run this part of the pipeline, part of the software that you need to reanalyze. And that way, like, you do not create those duplication. You don't spend time, you don't spend money on like analyzing and generating the files that you already have. And that applies not only to your like personal use, but like, let's say you have a laboratory and there like you have a set of files and two teams work on it, and then an intermediate file of one team analysis is actually required for the second team. And the second team like tries to generate it. The software sees, oh, okay, so like I have this file generated already here, like by this team one, and it just pulls that file from there with like there's no need to reanalyze this thing again, like even if it's like two different groups, because like we see every time the unique that is a unique file and it has been analyzed with a unique set of parameters, even if it's been like multiple softwares. So that speeds up the process a lot, because sometimes analyzing that kind of data can take like hours or maybe days if it's a huge data set. So it's very important to not waste time doing the same job 2, 3 more times.
Yeah, huge efficiency for the humans, the infrastructure, everything. That's great. Before we type, I do want to delve into the IT side of this a little bit. So, where does your software run?
It can be run on basically any platform. So, well, MiXCR, the command line software, can be run on like Mac, Linux, or Windows, but it's a command line. The Platforma will be also available for all of these. We have a version for Windows. It will be available for Linux. It will be available for Mac, for both versions of Mac with Silicon chip or the older versions. So pretty much any operation system that you have will fit.
Fantastic. And is it designed to share information, data, all within a single organization, or do you see different companies who are maybe collaborating, whether it's educational institutes, but people on different Active Directories and domain servers interacting with each other through your platform?
Obviously, yeah, there will be like an option to share it within an organization, and you can do that because, like, for example, if you work on a server, then the platform itself, the backend, is run on the server, and you just access the server from your laptop, having the graphical user interface. So, like, yeah, if there are like several different teams from one organization, they can all access the same data on this one server. In the future, we will, yeah, explore the abilities of how you can, if needed, share the data outside of this infrastructure. But
Okay.
currently, yeah, that is like mostly either your laptop or, and you can restrict access within the organization as well. Yeah, because like sometimes probably you don't want to give the access to your data to some other team for some reason. I don't know.
Right, sure.
Yeah, that is also possible.
Any number of reasons. Makes sense. Well, this is really interesting. Great, I say, progress for the industry. And conceptually, I think it really is going to help to simplify what's a really complex problem right now with data sets and getting insights. So I really appreciate you jumping onto the show. Can you tell us, if people want to learn more, what's the best website or URL to go to check it out on their own?
So our main website, I would say right now, is platforma.bio, and you can already sign in there, leave your contacts, so we will send you the installation file when it becomes available, which will be at the end of March. So I think that is the most relevant place to look for any information.
Okay.
And this will also become the after the release, like we will like change it, but the same address will be for like documentation on all the videos that are going to be like video tutorials and all the news regarding our software.
Fantastic. Well, good luck with the launch, the new technology that's coming out. It sounds like it's going to solve some really cool problems. I look forward to, hearing from customers who are using it in the future.
Of course, thank you for having me. It was a pleasure.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.